This video is for section 6-7, quadratic functions specified by this equation format. Function f of x is equal to x minus 1 squared plus 3. This is in vertex form that we learned in the previous lesson. We can quickly see that the vertex is the point 1, 3, and that helps us to make the graph. Now here's function g. It is also a quadratic equation because it has a second degree term, but it does not have the format of vertex form. However, this still has the vertex 1, 3. I'm sure you'll agree that it's the first function that's written in vertex form that is easier to identify the vertex. To figure out the vertex of a quadratic function that isn't in vertex form, transform the equation into vertex form. So I had figured out function g of x also has a vertex of 1, 3. Here's how I did that. Start by writing the equation of the function. Then transform it to vertex form, keeping in mind what you want to create. You need to have this term with the parentheses, and then on the end, the constant number. The term in parentheses is a binomial squared, and we know from our earlier work with factoring that a binomial squared is equivalent to a perfect square trinomial. Let's make a perfect square trinomial out of our quadratic equation. In a perfect square trinomial, there is a connection between the value of the constant term and the number that is the coefficient of x. Now, it's been a while since we worked with these, so let's review that connection. You have to figure out what half of this number is. Half of -2 is -1. Then you square this number. -1 squared makes +1. In a perfect square trinomial that has -2 as the coefficient of x, the constant term needs to be +1. The trinomial we have here doesn't have a constant term of +1. To change +4 into +1, we would have to subtract 3. But you can't just write a subtract 3 on one side of an equation. That would change the equation. To balance subtracting 3, write a +3 right next to it. If you subtract 3 from the right side of the equation, but then immediately add 3 to that, that doesn't change the overall value of that side of the equation. This process transforms the equation to look like this. Y equals x squared minus 2x, and then next to the minus 2x, write down the constant term +1, and then next to that, write down +3. Do you notice how the 1 plus 3 is equivalent to the 4 that we had to begin with? Next step, factor the perfect square trinomial portion of this as x minus 1 squared, and just leave the +3 on the end. Now we have vertex form, and you can see right away that the vertex is 1, 3. So changing a quadratic equation from this format into vertex form allows you to figure out the vertex. And from there, you could make the graph. The process that we used to figure out what constant term we needed to make a perfect square trinomial is called completing the square. Let's practice just that process a little bit. Let's say you wanted to make this polynomial be a perfect square trinomial. The process is to take half of the coefficient of the k term. Half of 12 is 6. Then square that 6 to get 36. 36 is the constant term that you would add on to the end. K squared plus 12k plus 36 is now a perfect square trinomial. If you ever needed to factor it, it becomes k plus 6 squared. Second example, to change this into a perfect square trinomial, you have to figure out what constant term you need on the end. To do that, what do you do with a -5? You find half of it. Half of -5 is negative 5 over 2. What do you do with that negative 5 over 2? You square it. Negative 5 over 2 squared makes 25 over 4. And that is the constant term that gets added on the end. Now we have a perfect square trinomial. If you had to factor it, what does it make? Well, it makes a set of parentheses, squaring on the outside, and it makes v minus the 5/2. This process of figuring out what you need to make a perfect square trinomial is called completing the square. In general, y equals ax² plus bx plus c can be transformed into vertex form as follows. To make it easier to get a perfect square trinomial, let's factor out the leading coefficient of a. Next, run through the completing the square process where you figure out half of the coefficient of x. That makes b over 2a. Then square the b over 2a. That makes b squared over 4a squared. That's the constant term that's in the perfect square trinomial. Let's rewrite our expression and insert that constant term. But you can't just add a new term to one side of the equation without compensating for it. Do you notice that the b squared over 4a squared is inside the parentheses with the letter a being timesed in front? By adding b squared over 4a squared in the parentheses, we've really changed the right side by a times b squared over 4a squared. So we need to subtract a times b squared over 4a squared. Adding the term here, but then subtracting this on the end, compensates, and you haven't changed the overall value of the right side. Please notice that an a on top and an a squared on the bottom will reduce to just b squared over 4a. Next, let's factor our perfect square trinomial. It makes a set of parentheses, squared, and inside x plus the b over 2a. We still have the plus c and the minus b squared over 4a. This fits the pattern for vertex form. Remember, that is y equals a times x minus h squared plus k. We have figured out that the value of h is negative b over 2a. And we have figured out that the value of k is c minus b squared over 4a. We've derived some general formulas for finding the vertex of a parabola and the axis of symmetry equation. The vertex of any parabola can be found with negative b over 2a, comma, c minus b squared over 4a. And the axis of symmetry equation is x equals negative b over 2a. With these formulas, you can take a quadratic equation, figure out the values of a, b, and c, and using substitution, find the vertex and the axis. Here are those formulas we just created. Let's try an example. For the function with this equation, find the axis, vertex, and the equation in vertex form. A is equal to 3, b is equal to negative 4, and c is equal to positive 2. The equation of the axis of symmetry is x equals negative b over 2a. The negative of b is 4, and 2 times a is 6. And this reduces to 2/3. So the axis of symmetry has the equation x equals 2/3. Let's find the vertex. The x-coordinate of the vertex we just figured out is 2/3. To find the y-coordinate of the vertex, we're going to use c minus b squared over 4a. So that's 2 minus b squared is 16. 4 times a is 12. And we can reduce this. We get 2/3 comma 2/3. The equation in vertex form is y equals 3 parentheses x minus 2/3 squared plus 2/3, where you're substituting a at the beginning, the value of h here, and the value of k on the end. Let's summarize the lesson. We discussed a process called completing the square, which you can use to change a quadratic equation into its vertex form. We tried the process on an equation with numbers, but also used the process on a general equation where we used a, b, and c to represent numbers. By working with the general equation, we created formulas that we can use to find the axis of symmetry, vertex, and equation in vertex form.